Hello and welcome to Suho's Introduction to PassivHaus Strategies webinar. In this webinar, we will discuss the benefits, technical requirements, basic principles of PassivHaus and how we can help you achieve them. At Suho, we are passionate about Australia's transition to a sustainable built environment, and PassivHaus is one of the methods in this direction. What is PassivHaus? It is a building standard developed in Germany to make comfortable buildings with low carbon emissions. This can be achieved by following the PassivHaus principles, which we will discuss in our coming slides. Why consider PassivHaus? If your building is PassivHaus certified, it means that it will be healthy and comfortable, it will have reduced energy demands along with minimized carbon emissions and low running costs, allowing you to prepare for future changes in climate. Additionally, even though developed in Germany, it requires the design to adapt to local climate, therefore making it suitable for wherever you build. These slides highlight the technical requirements that a new construction building needs to comply with to be considered for PassivHaus certification. The criteria are around the annual space heating and daily heating, primary energy demands, airtightness, window U values, and thermal comfort. For existing renovated buildings wanting to comply, the requirements are slightly lower than for new construction. They're outlined in this table here. This slide highlights the requirements for individual building components and alternate to space heating demands. There is another additional requirement that you can use. This slide highlights that the minimum thermal insulation if the requirements from the last two tables are not met. Those technical requirements can be achieved by adhering to the PassivHaus principles. It includes thermal insulation, air tightness, ventilation strategies, PassivHaus windows, and thermal bridge-free or minimum thermal bridge construction. Getting into them individually, the presence of a high-performance, continuous insulated thermal envelope wrapping the building is crucial in achieving the requirements for a PassivHaus build. This helps keeps the indoors warm during winter and keeps the heat out during summer. Due to the low U value or thermal transmittance requirement, for PassivHaus usually fluctuating between 0.08 to 0.15, high insulation is required. It can be achieved with different methods of construction such as masonry, timber, prefabricated systems, steel construction, or other such methods. The table here gives a typical range for U value requirements for different components of the building. It is not only the walls that need to be insulated, but also the roofs, windows, and floors depending on the location of the building. The exact U value specific to the project is calculated using the PHPP or the PassivHaus planning package. The requirements are based on a lot of factors such as location of the project, form factors, solar radiation, fenestration, local climate, and other such parameters. If you are more familiar with the R values, it can be quite easily calculated. It's just 1 by the U value. Airtightness. Now, airtightness is a method adopted in PassivHaus to prevent unwanted heat loss in the building due to air leakages. An airtight envelope enables higher level of thermal comfort within the building while also minimizing energy usage. It also helps reduce moisture content, preventing mold growth, and provides more acoustic comfort. Air leakages are very common. Some of the common spots for air leakages are around suspended floors, such as around joists, scaff left around surfaces. It could also be around windows and doors or fit-outs penetrating the building envelope, and so on. As a rule of thumb, you should be able to draw the airtight membrane or layer in plan or section without lifting your pen, as it is supposed to be continuous. The air tightness requirement for PassivHaus design is 0.6 air changes per hour at 50 pascals for new construction or 1 air changes per hour at 50 pascals for retrofits. To draw comparison, typical builds in Adelaide vary from 8 to 15 air changes per hour, some even exceed 30. To get more information into airtightness, you could watch our webinar series, which was linked to the last slide, or you could always get in touch with us and speak to our in-house airtightness expert. An airtight design requires mechanical ventilation for good indoor air quality. Mechanical ventilation with heat recovery systems, or MVHR, when installed correctly, plays a crucial role in satisfying PassivHaus design requirements. It recovers the heat from indoor air and uses that to warm the fresh incoming air from outside the building. It also helps keeps the carbon dioxide levels in check while providing clean air. The standard calls for 30 meter cube of fresh air per person per hour. To do so, the extraction volume is higher than that, depending on the zone of the building. One of the factors to consider when choosing MVHR system is the sound levels. PassivHaus dictates maximum noise level of 25 decibels in living spaces, while the extract location have an allowance of 30 decibels and the unit itself can be 35 decibels. This ventilation system must be integrated in with the design in order to achieve the sound requirements. PassivHaus windows are high-performance windows, typically triple glazed with insulated frames. Depending on the local climate, this might vary. While windows have a lot of important functions such as daylighting, solar gain, ventilation, connection to nature, the thermal performance of it is also key. The high performance allows it to perform functions while also reducing energy demands by preventing as much heat loss as possible. However, even high performance windows will still have heat and energy loss much higher than the rest of the building envelope. It is outlined that a PassivHaus window must achieve a U value of 0.8. This allows maintaining comfortable temperatures even near the windows. Integrated fenestration from early design strategies provides design opportunities. For instance, if the wall is quite thick due to insulation, this could be used as deep reveals, as in the windows could have deep reveals and that could be an expressed feature. Coming to thermal bridges are links in the building or conduction paths where the material has higher thermal conductivity than the surrounding areas, allowing heat to move a lot quicker. This creates problem because it enables heat loss during winter and gain in summer months. Minimizing thermal bridges to the maximum possible extent is important to improve building performance and comfort. The different types of thermal bridges includes construction thermal bridges, linear thermal bridges and point thermal bridges, thermal bridge free construction, geometric thermal bridge, and psi values. You could always look at our webinar if you want to find out more about thermal bridges, but if you want to build to a PassivHaus standard, you must consult with a PassivHaus certified consultant or a designer. Other principles of PassivHaus includes building fabric, windows, solar design, shading, summer ventilation, and roof lights. Fabric First rule prioritizes the building envelope to ensure it performs well, including high-performing insulation and air tightness, rather than focusing on external appliances first. Different construction methods can be considered on factors like the durability and performance. The success of PassivHaus relies quite heavily on a building fabric. Form factor is measured as the ratio of the external surface area to the internal usable area. A compact design helps achieve PassivHaus strategies easier. The table here outlines the typical form factors required by different types of buildings in a PassivHaus design. Solar design and shading must be designed to take advantage of solar gain in winter and keep the sun out in summer. A good fenestration design helps find that balance between heat gain and loss. The exact areas required becomes more clear when using the PHPP. The typical constructions that have been used in PassivHaus designs are masonry constructions such as cavity and solid masonry, timber frames, structural insulated panels or SIPs, insulated concrete formwork, or mixed methods that combine different types to maximize advantages by including benefits of the layers. However, the junctions between these mixed materials must be considered carefully. The 10-star homes design ticks off a lot of PassivHaus strategies, but it hasn't been certified yet. It has a super insulated envelope with insulated walls and roof. It is an airtight design with 0.63 air changes per hour. It uses heat recovery ventilation and the windows are triple glazed, argon-filled with thermal breaks. PHPP or PassivHaus Planning Package is a design tool which is populated during the design process. It is complex but gives accurate results. It is a great tool to test different design options and check their performance. After designing to PassivHaus standards, it is possible to get certified as long as they comply. It is an independent process carried out by the PassivHaus Institute or an accredited certifier. How can we help you? At Suho, our design team is familiar with the strategies required for PassivHaus. As mentioned in our previous slides, our in-house PassivHaus certified consultant can help you attain the results you need and also certify your designs. However, it is important to note that engaging in this process early is crucial to success and also in cost savings. If you have any further questions, you can visit our website, give us a ring, or drop us an email. That's it for today's webinar. Thanks for tuning in.